So the underlying message is that if you're unsure whether or not a rotational signature is legitimate, use multiple radar products to confirm, as well as the rules of thumb we discussed. Let's take a look at a couple examples. Let's say you're out chasing and you're approaching this storm. We can clearly see that it's a supercell. It has the classic V-notch or flying eagle. It has a robust reflectivity core with very tight reflectivity gradients along its outer edges, and it has a clear kidney bean shape with a little bit of an appendage on its west or southwest flank. Then you notice this rotational signature, but you're not sure if it's legitimate. Let's go through our checklist. The first question you can ask is it in the right part of the storm? If the answer is no, you can usually disregard the signature altogether. In this case, the answer is yes. It's clearly coincident with the supercell's appendage. But let's go through our other rules of thumb to make sure. Is it symmetric across a radial? Yes, it's clearly split in half along a radial, with our enhanced inbounds on one side and enhanced outbounds on the other. Has it been persistent? If we go back a few minutes, we can see that there's been some sort of rotation in that area of the storm for multiple scans now, so yes, it has been persistent. Does it have vertical continuity? If we go up in tilts, we do see some sort of rotational signature all the way up to tilt 4. So we've been able to check all of our boxes. Where's our radar? Down to the south of the storm, so this is definitely a legitimate cyclonic rotational signature, and with a maximum inbound velocity of negative 32.4 miles per hour and a maximum outbound velocity of 76.1 miles per hour, that gives us a delta V of over 108 miles per hour at a distance of about 60 miles from the radar, which satisfies the criterion for a tornado vortex signature. Can we confirm a tornado with this TVS? Taking a look at correlation coefficient, we don't see a concentrated area of lowered values coincident with the TVS. Although we do have lowered values here, they're part of this broader area of lowered CC, rather than a concentrated area of significantly lowered CC compared to areas around it. You could also look at differential reflectivity and spectrum width, but unfortunately this particular archive is missing those products. So there's not enough evidence to confirm a tornado debris signature and therefore a tornado with this couplet, but it's clearly a legitimate tornado vortex signature.
Join our channel membership and unlock instant access to full-length storm chasing presentations. Click the subscribe button below and then select join, or just click the join button on our profile page.
How about another one? Here again we have a supercell with an apparent cyclonic rotational signature. Right away, however, we can see that it's not in the right part of the storm. Instead of being co-located with the supercell's appendage, it's situated on the edge of the forward flank. This should immediately tell you that this signature is bogus, but to make sure, let's go through our checklist. Is it symmetric across a radial? Yes, it actually is. Has it been persistent? Going back a few scans, it seems to appear out of nowhere with little sign of any pre-existing rotation, so no, it has not been persistent. Does it have vertical continuity? No. As we go up in tilts, there's no evidence of any mesocyclone or vortex in the vertical. So, while at first glance it appears to be rotation, it fails a number of points on our checklist and therefore is not a valid vortex signature.
Remember to check out those links in the description below and then watch another video.